Hello, everybody, and welcome to one new session of Polkadot Deep Dives. Today, we will be covering Asset Transfers API, a tool that allows for a very easy integration with everything asset management related. During today's session, I will give an overview of this API. We will cover some interactions, what that looks like, and then I will pass it to my colleague Tariq, which will follow up with the design as well as other end-to-end workflows, and ending up with a demo, a deep dive. So let's get started. First of all, everybody here in the session today is getting alpha. Well, aside from this joke, this API, this tool, is getting close to its beta stage, so it's still in development. This means that, well, not all the decisions that are made have to be final. They might change, or some implementation details might change, but what we are showing today is pretty much like working fine. So it's a good moment for covering this, right? Just, well, as a warning, I guess, like, it's fair, right? Then let's start with a brief description. What is Asset Transfer API? Well, the Asset Transfer API is a library focused on simplifying the construction of asset transfers for substrate-based chains, basically, and it double clicks and it like puts all the focus on everything involving like system partitions, like it's a statement for the Polkadot environment, right? As you might know, like this system partition statement concretely is like the asset hub for the ecosystem. It's supposed to be the asset hub for the ecosystem. And to make this happen, to ease this view of having this reserve that all the community can leverage, we need the proper tooling in there to make sure that every player, every stakeholder of the ecosystem, this includes custodians, changes, like the end users themselves, everybody has like the best experience when managing these assets, when depositing them, when withdrawing them, when sending them to other chains, right? And well, so far today, like this, let's think about custodian source changes. Like they need to maintain infrastructure and different tooling for sending assets to different chains, right? Well, this tool, this library, this API will allows like all these like transactions to happen without needing an extra effort in the infrastructure side, by like interfacing directly with the statement and then having the correct calls in place to let the whole following calls happen. We will double click into this like a few slides later, and it will be much clearer. So, how this works, right? A little bit, just a broad overview, some detail. Like we will cover us like way better with this. Like it exposes like a reduced set of methods, right, which facilitates users to send and transfer to other partitions or locally, like these assets that we have in here. Most of the details, or at least, for example, if we look at the example that we have on the screen, which is like a create transfer transaction, one of the methods that the asset transfer API exposes, we can see that, as you can imagine, like most of the parameters will come from the end user side, right? And under the hood, the tool will construct the relevant extrinsic, perhaps allow the user to sign it or not, depending on the flow, the scenario. and then like perform the relevant calls, right? Most well, all this process for the user will be transparent, um, and if this transaction involves emitting any XCM messages to another party, then will be it, right? Like the API will take care of composing everything necessary to fulfill the instructions that were given, like this at the very beginning. I Before passing to the next slide, I would like to mention that at this point, at this stage of the API live, it covers integrations from system parachains, either to another sovereign parachains or relay chains, and from relay chains to system parachains and other sovereign parachains, and of course local transactions. So with this code that we have in mind, let's pass to the next slide, because as we can see, there are different parameters that this method can receive, right? And this can be like destination chain, destination address in the chain, like the assets that want to be transferred, the amounts for those assets, and then some options. Okay, so let's see what are those options. These it can vary, right? This is the list of options that that parameter accepts at this point, and this could be like the format of the result that we want, right? It could be like submittable extrinsic. It could be payload or call, which will return like an X encoded bunch of data. Then we can define how do we want to pay fees with. Will this default to the native token of the relay chain? Will it default to some asset? Like we can define this here. With what pays fee with 2? This is more or less the same than the later one, but referring to the destination part. So it changes context a little bit, but definition will be like very similar. Is limited. This let us define if we want to set some weight limit on certain operations that allow them. And as you can imagine, like next option, which is weight limit itself, in case like is limited is true, weight limit will be like that set limit. If this is not imputed, then it will default to unlimited, and we'll have the unlimited or not limited versions of those transfers, right? That we want to perform. XCM version, clear that name that allow us to set the XCM version for the messages that will be encoded with the version that we define here. And if it's not present, it will use like the safe version stored in that runtime. And lastly, we have like keep alive that will be used for creating like local transfers with the transfer keep alive extrinsic. All right. This was just a quick overview. Let's jump and let's see. Oh, I think this is not showing, right? Let me just reload this page and we can. All right. Sorry about that. I don't know what happened. What do we have in here? So this is a little bit the user journey that we will see when interfacing with the API. If we do like if we want to, in this case, for example, we have sent some assets to some account in another party, right? This will be like more or less the 101. In this case, the user will ask the custodian is interfacing with the exchange, whatever app client that it's in between him and the chain itself. To do this for him, then this custodian, this actor, will interface with the API, right? Let's jump to the next slide. All right. As we can see here, like based on the parameters that the user has specified at the very beginning, uh, the asset transfer API will create the relevant extrinsic. Then the API will return that to whatever system there in this change in the custodian, and if needed, it will prompt the user to sign. After everything is in place, this extrinsic will be like dispatched, right? Will be sent to the chain to be dispatched, right? If you see in there in the diagram, well, this flow will commence like down inside the custodian 2.1 with the call to the asset transfer API. This could be like invoking like the method that we have seen before with the pertinent parameters. The API will result with an extrinsic already constructed, maybe sign it, send it, right? And the chain will eventually receive this. This extrinsic can like very well like be sent to a statement and result in another XCM messages that will be sent outside of a statement afterwards. But the main point is that the custodian here will only interface with a statement, even though these assets are meant to be sent elsewhere, or there are some more messages that are meant to be sent to another chain after that. Everything that the custodian sees or the user sees or whomever that is interacting with this transfer API is only one chain. That's the whole point. Lowering the complexity on all the infrastructure and overhead that brings with it, right? After that message is sent, well, then there will be a receipt for the user, so he can track this transaction. He can see if it has been like finalized or not, or like all the details in like an Explorer or any other tool, right? And with this, I will pass it to my colleague Tarek, that will illuminate us with a lot of technical details.
Cool. Hey, everyone. So my name's Tarek. I'm one of the main developers on the Asset Transfer API, and let's dive a little deeper into the technical aspects of it. So let's first start off with the dependencies. We try to keep the top level dependencies very simple and bare. We don't want to add too much overhead to the actual API itself. So there is only two dependencies that the Asset Transfer API is going to digest. One is the Polkadot.js API, and we leverage a large portion of this WebSocket connection as well as its type generation system. Now, the type generation system is super important for our XCM construction, and that's a large part of our entire logical module separation and decoupling of quite a lot of our components inside. And then we have this substrate asset transfer API registry. Now, this registry is a zero dependency library that we developed, and this library is a source of truth for all the tokens and asset IDs that live under certain parachains or relay chains. And to expand on this, let's look at the structure of this and how it looks like. But before that, just to elaborate, let's say the registry itself doesn't have certain tokens or doesn't recognize your parachain, you can actually inject this data in. This might happen because, or if this might be limited because what we do is we pull in Polkadot.js's apps config, which has a bunch of parachain teams that register themselves with apps. So let's say a parachain teams is not, data is not in there, you can inject it yourself and the API will recognize that. Cool, but the structure of this works with first, the first keys are going to be the relay chains. And in this case, it's just going to be Polkadot, Kusama, and West End. Underneath, you'll see this zero here, and that zero is what we identify as the relay chain itself. So here we have the native token of dot. The Polkadot doesn't hold any asset uh, information for any assets on, let's say, like statement, for example, um, and then the spec name. Now it will go down to the next ID, the next one, which will be statement, and so on and so forth. So this will technically have all of the parachain IDs underneath Polkadot, and then it'll go to Kusama and then West End and so on. Cool. So let's actually work through what the extrinsic workflow looks like underneath on the Asset Transfer API. So first, you want to establish an API promise. So we give you tools in order to create one if you don't want to actually have Polkadot.js locally, or if you do have Polkadot.js locally, you can create one yourself. But the Asset Transfer API requires to digest an API promise in order to hold this open WebSocket connection to gather certain information needed to construct these extrinsics, calls, payloads, whatever it may be. So after we establish or instantiate this class, we can call create transfer transaction. Now, what does create transfer transaction do? The first thing it does is it establishes a transaction direction or an XCM direction. Now, this is a pretty fundamental part of our API because it declares for us where is the origin and where is the destination of this call. So the transaction direction might be locally, and that'll be a little more simple. It'll either use the assets palette or the balances palette, and we'll touch on that more in a future slide. Or it might actually require cross-chain transfer. In this case, we'll have to create XCM calls for that. Now, after we declare an XCM direction, then we decide whether it's a cross-chain transfer or local transfer. And then all of that data is going to go into our input validation and error layer. Now, this ensures that everything you input is correct. And what that means is, are the tokens or asset IDs you put in, do they exist? Is the values you put in for the amounts, do we make sure that you haven't duplicated anything and added extra values? Also, in general, we'll just check every single edge case that we can for the specific direction that you're in. So, for example, if you're sending a transaction from a system parachain to a sovereign parachain, that might have many more cases to look for as would sending a transaction from a relay chain to a system parachain. So every direction has their own edge cases if we try to cover all of those. So after this input and validation error layer, then we actually construct the transfer. And then from there, we actually return the format that you specify. And if you haven't specified a format, then we'll refer to the default. Cool. So let's actually kind of look at what that API promise looks like. So we have a construct API promise, and this is what we provide to users if they don't want to construct their own API promise and they don't want to have Polkadot.js as a dependency. So in this case, it's pretty simple where all you're going to pass in is the WebSocket URL for the chain that you want to connect to, and then any additional options in the API that you want to add. And then from there, as you can see, then you just pass in that API to the Asset Transfer API. Cool. And this is what a small example of what it looked like. It's pretty limited code. And this right here is a sample transaction as to what it would look like from passing some Westies from West End to a system parachain. Now, what we could see here is that 1000 is denoting the destination chain ID. So in this case, it's going to be Westmint. And then we have this ID here, which is the destination address in which we want to send those funds to. Now, we have this asset IDs field, and in this case, because we're sending the transaction from a relay chain, we can actually keep it empty because there's only one native token in this case. But if need be, you can also specify if, like, for example, in the future, if a parachain has multiple tokens, you can specify the one that you would want to send. And then this is the amount that we're going to be sending. And then And then these are some options we have. Now, these options, in this case, we're just setting the format to a call. we're saying we want this to be is limited, but because we're not applying a weight limit, it's going to actually be unlimited. And then the XCM version that we want to declare. Now, to touch briefly on this, the Asset Transfer API only supports two XCM versions at a time. So in this case, we are supporting 2 and 3. So when 4 comes out, we'll have a rollout where we support 3 versions for a soft transition. But once all chains then convert to 3 and 4, then we would only support 3 and 4, and so on. Cool. So let's touch more on this XCM direction. So it's our way of declaring where is the origin of the XCM transaction transfer we are generating and where's the destination. This allows us to ensure we keep our code clean, maintainable, and debuggable. And as you'll see too, we also provide the XCM direction in the return output. And this is all for logging and debuggable reasons. We'll have ways to remove that too if the user wants to keep things cleaner, but it's a good way for us to track the lifetime of a XCM transaction. So as of today, there are 7 directions that need to be covered, but only 4 of them are fully supported and stable. So system to relay chain or a relay to system, so sending native tokens back and forth between a relay and system parachain, and then system to para, sending any tokens from a system parachain to a parachain, and then from a relay chain to a parachain. Now, the 3 unsupported you see here is para to relay, and para to system. Now, these can be a little complicated in the sense of palette naming for parachain could be different from parachain to parachain. So we're working on a way to centralize and make it very easy for us to identify what the actual palette names are per parachain so that we can have a reliable way to construct and get the information that we need. So currently that's in active development and hopefully will be out in the future. So let's go over some notes really quickly on cross-chain transfers. The API supports 3 relay chains, and those are the main ones, is Polkadot, Kusama, and Westend, and then all their respective parachains. If your parachain isn't in the registry, as said earlier, you can inject any data that you want. We in the Asset Transfer API use the number 0 to represent relay chains IDs. So for the system to para direction, the API actually allows you to send multiple assets at once. And a big important thing to understand as well is the API is smart enough to recognize whether you need to have a teleport assets or a reserve asset transfer call. Now, this is super important with the way that relay chains and system parachains and sovereign parachains work on trust and security, and whether or not the asset you're going to send is native, foreign, or recognized as trustworthy. Now, each XCM direction, as touched earlier, has its own nuances. So therefore, the API actually treats every direction separately, and no logic is coupled between them. So let's go over local transfers really quickly. So we support 2 palettes. That's the assets palette and the balances palette. And as the time period from switching over to transfer allowed death ends, we'll have a pretty easy transition from one to the other. But until that 3-month period ends, we'll have support for transfer and transfer keep alive. And for any relay chain transactions, it'll always be the balances palette. But depending on a system parachain's palette, depending on a system parachain's transaction, that will change. Because depending on whether, like for statement, for example, if you're sending dot, we want to make sure we use the palettes, the balances palette, or if you're sending assets, we want to make sure to use the assets palette. And the API will detect all of that for you and set up a correct transaction. Okay, cool. Apologies if the text is a little small. During the demo, we'll have a chance to zoom in and see this closer. But this is an example of the return value that the Asset Transfer API is going to give from create transfer transaction. Now, as you can see, you have a direction. So this direction is actually going to be the XCM direction in which the call is made. And then we have the XCM version. So this is the XCM version that was used to create the call. We have the method that was used. So in this case, you can see limited teleport assets, but depending on the direction and also the tokens or asset IDs you're sending, that may change. This is the format, as you saw in the options earlier. So the format may also change, but in this case, we have it as a call. And then you can see the transaction. And this is the meat of the extrinsic itself. And this is what you're going to be using to either sign and send. Um, cool. So let's go over. So call is just going to be a hex string as well as the payload. But what's interesting is we have this submittable option. And this submittable option is going to be a Polkadot.js submittable extrinsic. And what does that mean? It means that it has a lot of uh, functions attached to it that allow you to do things locally pretty easily, such as sign and send, sign a sync, sign, and then you may do whatever you want with that object. But this just allows you to not have to convert that type locally if you do not wish. Okay, so let's talk about what we expect in the near future. So yesterday, this actually just went in, but the ability to decode your transactions. So this should be going in the next alpha release, which should be on Monday. So one thing we are currently lacking and we are really going to put into high gear soon is more documentation, especially more examples. So we want to be able to cover every single example possible for you that to make it as easy to integrate as as needed. And a really one that I'm pushing for and I hope to get in soon is a more robust registry that allows you to have a bunch of getters and lookup patterns to find what the asset actually has and supports for you. Cool. Let's do a quick demo, and this demo is going to show from end to end what it looks like um, from a blank directory on how quickly we can make a extrinsic. Cool. So we're in this blank directory called demo. Now let's do an npm init. Oh, okay. 1 second. We're going to have to do a quick. Cool. Awesome. So now we have our package.json. Let's add this asset transfer API to it. So sweet. Now let's just ensure that we have the correct. Awesome. And as you can see, we have this available. Awesome. So currently we have the Alpha 4 version, which is perfect. Now let's touch an index.js file in here and let's do some coding. Awesome. So the first thing we want to do is let's add cool. And let's add the asset transfer API and construct API promise in here. Awesome. Now let's make a main function. Let's call main and let's put finally, let's add this callback. Awesome. Cool. Now let's construct the actual API promise because let's connect to the actual chain. Let's add this WebSocket in. Let's connect to West End. And let's make sure that we do API is ready to ensure that we don't start querying too early. Now, let's create an assets API. So and let's pass in the API in. Cool. So let's create our first call. Let's do const call equals, and we could do await assets API dot create transfer transaction. And from here, we're going to add in a bunch of values. So we want to, in this case, let's send some West End from West End to West Mint. So we know that chain ID is 1000. Let me just grab really quickly my test account. So let's pass it to this test account. And then we know we can, as mentioned earlier, pass in an empty array because we know the API can detect it because this is starting from a relay chain that we're just going to send the native token. And let's pass 10 West End. And in this case, I wrote it down just in case, just so we don't have to count the zeros. And let's pass in some options. So in this case, let's do a format. Let's do call. Let's do is limited. And then let's also set the XEM version to 2. We could do 3 as well, and that's supported. But in this case, let's just do 2. Cool. So let's actually just console.log what this call looks like so that we could see exactly. Awesome. Sweet. So we have this callback. It knows that this is going to be a relay to system parachain. It telling us the XEM version it used to construct. This is a limited teleport assets, which is correct. We use the call and we use it. This is the transaction call. So instead of sending this manually through here and having to get our mnemonic, let's just actually go to Polkadot.js so we can have a more visual aspect to see what this actually looks like. And beforehand, let's just note that we have 29 West End on Westmint currently. And on West End, we have 79. Cool. So let's go to the extrinsics tab and let's put this value in here. And let's see how it's decoded. Awesome. So it's correct. So we have this correct destination call. This beneficiary is correct as well. And then it has these assets passed into us. Cool. So now we could do a submission. Let's submit this transaction. Let's sign and submit it really quickly. Awesome. So the transaction has sent. And as you can see, the value went up. Oh, it just went up a second ago, but huh. And let's go to accounts tab here. So this is minus. And there we go. So the value has now increased. And yeah, so that's how simple it could be to send any transaction from one destination to another. Of course, this can get way more advanced when it comes to parachains and sending between parachains and system parachains to parachains. But this was just a quick demo to show you how you can get up and running. Thank you all for joining. This was really awesome, and it's really cool to display the work we've been doing for the past few months. Hopefully, this simplifies the process for a lot of individuals and exchanges and custodians on how they could build these asset transfers without having to step into the complexity of XCM. And thank you all for your time.
Thank you, everybody.